Okay, class, today we're going to be looking at lesson 4.6, the Pythagorean theorem. So this is just a review of something you've done probably a bunch of times before. So remember that we have a right triangle, a triangle with a 90-degree angle. The right triangle is marked with a small square, so you can see that on the picture to the right. And the two shorter sides are called the legs. So you can see the legs in the diagram here. There's a leg and there's a leg. And the longest side is called the hypotenuse, and it's opposite from the right angle. So that's called the hypotenuse. It's always opposite from the right angle. When we draw a right angled triangle, we always label the hypotenuse with a C. So we're going to call that C. And we label the legs A and B, and it doesn't matter which order, A and B. So the legs are A and B. And the Pythagorean theorem states that C squared is equal to A squared plus B squared. Or A squared plus B squared equals C squared in a right triangle, where C has to be, in both of these cases, the hypotenuse. So hype for short. So it has to be the hypotenuse. So we can use this to calculate the length of missing sides. So here's two triangles. For each triangle, calculate the missing side length. So the first thing I'm going to do when I get a triangle, a right triangle, is label the hypotenuse. And it is opposite from the right angle. So I'm going to label that C, and I'll call the other two sides A and B. And I'll do the same thing with this one. Well, actually, let's do one triangle at a time. So we have that A squared plus B squared is equal to C squared. I'll write the C squared first because that's what we're solving for. C squared is equal to A squared plus B squared. So that C squared is equal to, well, A is equal to 5. So I'm going to put 5 squared. And B is equal to 12. So plus 12 squared. And hopefully we have a calculator handy, which of course I don't. I'm going to have to do this in my head. So C squared is equal to, first we square the 5. So BEDMAS tells us to do the exponents first. If I look at BEDMAS, I'm doing the exponents first. So, well, brackets first, but there aren't any, so we go to exponents. So that's 25. And then plus 12 squared in your calculator, you have a little square. And remember that 12 squared really just means 12 times 12. So if you can't find the button in your calculator, you could type 12 times 12. That's 144. And then add those together, then we get C squared is equal to, so looking through, we don't have any division or multiplication, but we have addition and subtraction, so we're going to figure that out. That is 169. And then to get the C by itself, if you remember back to solving equations, we're going to take the square root of both sides. So I'm going to take the square root of C squared and the square root of 169. And the square root of C squared is C, because square root undoes square. And the square root of 169 is 13. So the length of side C is 13, and I can look back on my triangle to see that it's centimeters, 13 centimeters. So taking a look at the next triangle, once again, we're going to label the opposite side with a C, and the other two legs can be anything you want, A and B, in any order. So in this case, I made my B 4. And so to do this one, once again, I'm solving for C, so I'm going to say C squared is equal to A squared plus B squared. So that tells me that C squared is equal to, well, A is 8, so 8 squared, plus B is 4 squared. So I'll do each of those. So C squared is equal to 8 squared is 64, plus 4 squared is 4 times 4 is 16. I'll add those together to get C squared is equal to 90. And now I actually need a calculator, and I don't know how to pause this, so fast forward for a moment while I search for a calculator. pardon me. So in your calculator, to get c all by itself, we're going to take the square root of each side. And the square root of c squared is just c. And the square root of 90, if you do that in your calculator, is 9.5 approximately. So it's 9.4868. I'm just writing all the numbers down that are written in my calculator. I'm going to round to 1 decimal place. So when I look at the 1 decimal place, I look to the right of it and I say, is this number bigger than 5 or less than 5? So it is bigger than 5, so that's going to make this go up 1. So when I round, that'll be approximately 9.5, and look back at my triangle to see that that's centimeters. So this little dot up here means approximately. So that says or about 9.5. So I have to round when I get to questions like this. So that was 9.5 centimeters. Coming up to the next set of questions. This time I'm going to take my right angle, and remember I'm labeling the side opposite with a C. And then the other two, the legs get A and B. So this time I'm going to be solving for B. So B is what I'm looking for. So I'm going to start with A squared plus B squared equals C squared. And I'm going to substitute 3 for A, so that gives me 3 squared, plus we don't know what B is, so we're just going to keep that at B squared, equals, and C squared is 12 squared. Now, before I go about solving this, because we do see that we have to solve this, I'm going to simplify the squares. So, I wonder why it keeps doing that. So I'm going to simplify my squares. 3 squared is 9, so I have 9 plus b squared equals 12 squared is 144. Now, I want to get the b by itself. So think back to the stuff that we learned back in solving equations. I'm going to put a line down this. Looking at the left-hand side, I'm solving for b squared. I want to get rid of that 9. It's being added on, so I'm going to subtract 9 from both sides. And when I do that, I get b squared by itself equals 144 minus 9, which is 135. Now I want to get b by itself, so I'm going to undo the square, which means I'm going to do the square root of both sides. And I get b is equal to the square root of 135, which is approximately 11.6. And again, that's centimeters. So notice this time we had to undo the equation. We had to get rid of the 9 on the left-hand side before taking the square root. So let's do another one like that. If you want, you can pause it and try it on your own. So this time, across from my right angle is my C. And then I label the other two legs, doesn't matter which. I'm going to make this B and this one A just to mix things up. So again, I have A squared plus B squared is equal to C squared. I'm going to substitute. In place of the A, I keep A because there's nothing there. Plus, in place of the B, I'm going to put 7, so that's 7 squared. And in place of the C, I'm going to put 25. So it's 25 squared. So here I get A squared is just A squared. We're evaluating right now. 7 squared is 49. And 25 squared is 625. Now I'm looking at an equation I need to solve. So I'm going to draw my line. I want to get A squared alone. There's a plus 49. To get rid of that plus 49, I'm going to subtract 49 from both sides. And then on the left side, I'm left with just A squared. And on the right side, I get 625 minus 49, which is 576. And we haven't finished solving it because we have a squared. We want to get rid of the square on that, so we're going to take the square root of both sides. And when we take the square root of a squared, we get a. And when we take the square root of 576, we get exactly 24. So we don't need the dot above the equal sign. And this is in centimeters because it's in centimeters in the diagram. So my final answer is A is equal to 24. So notice that there's a difference between when you have the hypotenuse and when you don't have this hypotenuse. So we'll do one more just like that. Again, start by labeling your, labeling your C, which is across from the right angle with a C. So this time I have my hypotenuse. I'm going to do this as C squared equals A squared plus B squared. And I'm going to substitute each thing in. C is X, so I'll change that to X squared equals A squared. Oh, I didn't label my two sides. Let's make that A and that B. So A is 9, so that's 9 squared, plus B is 12, which is 12 squared. And now I'm just going to evaluate all the squares that I can. X squared I can't do anything with. I'll just leave it squared. 9 squared is 81, plus 12 squared is 144. Add those together. So the x squared is all by itself, so I'm just adding 81 and 144 together. That gives me 225. And now I can solve for x. Take the square root of x squared, the square root of 225, and I get x is equal to 25. Is that right? No, it's 15. Let's erase that. Where is that? I think it's 15. I didn't actually try it in my calculator. It's 15. 15, and this doesn't have units, so we stop there. Let's look at the difference between that and when we have C given to us. So if we look at the next triangle, notice that the opposite side, C, has a number on it. We label the other two sides A and B, and I'm going to start this one with A squared plus B squared equals C squared. It really doesn't matter which order you write that in. Replacing what I have, so if A is 24, so we have 24 squared plus x squared because B is x, and C is 30, and we're going to square that. So we'll do that in our calculators. 24 squared is 576. X squared stays the same. 30 squared is 900. Now notice that x is not alone in this one, and so we can't just take the square root right now. We're actually solving an equation. So the x squared has a 576 attached, and it's attached by addition, so I'm going to subtract 576 from both sides because the opposite of addition is subtraction. And on the left side, that leaves me with x squared because these two cancel out. And on the right-hand side, we get 900 minus 576, which is 324. Then to solve for x, then we take the square root of both sides. So that leaves me with x squared on the left, and the square root of 324 is 18. So notice the difference between these two, solving these two equations. The biggest difference is that here we simplify and then we take the square root. And here in the right-hand side, we actually have to solve and then take the square root. So we can say when we don't have C, we simplify and then take the square root. When we do have C, we have to solve and then take the square root. So you have some, I missed a word here. You have some examples or some questions to try out on the next page when we do have C. Just highlight those when we don't and when we do. And so take a look at those, and hopefully you will remember this.